what is the future of the lakehouse?
Future's bright.
It's not easy, it's hard.
I think the evolution of it. Oh, yeah.
Are they working? Are they? Yeah.
Test, test.
You guys can hear us with the mic.
Yeah, I think from where lake houses were 5-10 years ago, or approaching that now, they were complicated. People didn't put any data modeling into it. It was all schema on read. I think what Iceberg's provided is a source now that can be interchangeably shared with all of the associated metadata that provide the context to make more value from it. So, I'm interested to see all the stuff about materialized views, where that's going. I think there's a lot more possible. Exciting.
Yeah, I mean, I would just add, it was very interesting to see the topics that were covered here, right? Materialized views, change data capture, data modeling. I think it's a sign that the lakehouse is reaching a real maturity, that we're able to apply these tried and true approaches that, when I started my career 15 years ago, we were doing many of these things, but it was on Oracle, right? And they're very useful. The fact that we can now apply them to the lakehouse, I think, is a really good sign that this is becoming a much more mature technology that can address many, many use cases within a business.
I always say, I use the term, look to the past to innovate for the future. So there's lots of stuff that, I've been around a bit too long. I don't want to admit how many years I've been in this data industry, but I see this, it's repeating, but a refinement that's happening. So, materialized views were in Oracle 9, or probably, I think maybe in Oracle 8 they were introduced, but, we're going back many, many years. So for those things now to be adopted in open source projects that are available to anyone, is a door opener to providing technology that can make your company a disruptor, or which without having the bank of a small country.
JB, did you want to add anything?
Yeah, I think that I agree with you guys from a user standpoint. From a technical standpoint, I think for me the future is going to be interoperability, because we don't want to create silos on lakehouse architectures. If we have 3 lakehouse platforms in your company, it's going to cost a lot and it's not super efficient to move a workflow from one platform to another. So for me, from a technical standpoint, I think that the most important, it's going to be the interoperability and openness of the different layers of a lakehouse architecture.
Yeah, I'd say that probably the thing that I'm at least most excited about in the future is that new use cases, I think, are going to start opening up. I think that up until now, analytics has kind of been the bellwether, kind of the first use case that's almost completely migrated to lakehouse architectures, and definitely is very mature there. But there are a lot of different use cases in the data world, and just like the same way we saw proliferation of NoSQL databases maybe like 10, 15 years ago, I think we're going to see proliferations of different specialized use cases in the lakehouse, which will give the same benefits of much lower cost and more flexibility, but in a broader range of data usages.
Yeah, actually, I'd like to go into that. If you guys have use cases that you've seen,
Yeah, good prompts. We were just having a chat just before in the coffee area. Yeah, I mean, there's a couple of use cases. One use case that wouldn't have been available before, with the old approach of having S3 files with a glue catalog on top of it. The right to be forgotten, it's a very British thing, GDPR. And people can request their information to be deleted if it's stored in a very large file on your lake. The process to go and resolve that was complicated. You have to bring the whole file in, change the file, write the file back. That's now been simplified with Iceberg. I can delete a record or remove a node within there without having to go through that process. So that's now opened up use cases for a particular client where they didn't want to go that approach because they didn't know how to solve that problem, or it was too complicated or too costly to solve that problem. So now they've adopted that approach. They've saved some costs, they simplified the process, but also they're compliant. So they've reduced the risk of any fines. So yeah, that's one particular one. I've got another, but I'll save it for a bit.
I think for me, one of the most interesting things, so sort of my background is more in data engineering and architecture, is just in making everything a lot simpler, right? It's like if you've got a database, be it Oracle or like your Snowflake instance, you likely already have some kind of object storage where you've got your data. So the fact you've got to move it there is just an unnecessary step. And I think this is what was most exciting for me, because you guys were all sort of speaking so highly of Iceberg, so I sort of checked it out way back in the day, and you couldn't really do anything with it. It was like, okay, great, I've got all these files in my lake, they're in Iceberg instead of Parquet, now what? Can I have like a Oracle or a Snowflake-like experience? Can I do the things I'm used to be doing? And you couldn't. And the thing which is interesting for me now is you're getting closer to it, and I know I'm probably more bearish on this than the rest of the panel, but it is pretty cool to see how the use case of simplifying your architecture is something people are employing. And why do we want to do that? One, cost, two, security, right? Yeah. It's like minimize your surface area of attack. Happy days.
Ease of use too, right? You're expecting that sort of warehouse-like experience, so it opens up to different personas like analysts, data scientists, et cetera. What about you? On the have you seen BI use cases where folks are using Iceberg?
Yeah, well, I mean, one, we have an interesting one right now at GoodData, which is we're beginning the process of actually integrating Iceberg into our data federation and caching layer, right? So we kind of, one of the things we're doing is, there's a lot of classic BI problems that you try to solve around metric creation and materialization of data into the BI layer that maybe people always set out. Like anybody who's building a new lakehouse or warehouse says, oh, we're not going to do that stuff in BI, right? And then 3 years later, they've done a ton of it in BI. And so one of the things that we're actually doing with the product is we're embracing Arrow, DuckDB, and Iceberg to kind of open that BI layer to standard open source technologies so that when you are defining things within BI, that you have the ability to easily get them out of BI and use them in other places. Because locking your analytics into the BI layer is actually a big problem for a lot of our customers. So one of the things I'm interested to see is, as opposed to the previous generation of tools and technologies, like we mentioned Oracle, as the head of product at a BI vendor, I would have never, ever in a million years used Oracle as a fundamental component of my software. It would have been insane. But now I can do that with Iceberg because of the open source approach. So, I'm curious. I think it'd be pretty interesting. I think many software vendors are going to embrace these types of technologies as core pieces of their software stack because we get so much out of it, and we don't suffer the immense pain of having to choose a proprietary commercial vendor for this sort of thing.
What about sort of client use cases from your perspectives? Do you have clients that are using Iceberg in interesting ways?
Yeah, for sure. I mean, at Dremio, we are based on Iceberg, so we have a lot of, I would say that the use cases are almost infinite. We have different business domain, different use cases, large use cases. I think the most important is, and back to what you said about open source and all this stuff, it's pretty important to have, because you can twist Iceberg in the way you want to execute the best for your use case. Mm-hmm. And for us at Dremio, it's pretty difficult to have a query engine which is abstract to any kind of use case. So for instance, you talk about materials view, is something that we have for a while. The name is reflection, but it's basically the same kind of concepts. And we're involved in materials view with Jan and others. So I think that the use cases are infinite. The main question you may ask yourself as a user is, what's the benefits in terms of cost, deployment model, and performances? And then on these three criteria, you define what's the best architecture, what's the best tool, what's the best, could be this query engine for this use case, this query engine for another use case, or you twist, data files, maybe not in Parquet, but in Orc, because it's better. I don't know, but that's the kind of reflection you should have for yourself.
So you're saying like lots of flexibility and sort of knobs you can turn to get it right for your use case.
Yeah, so back again, interoperability, because you have to concentrate some layers on different tools. That's the first thing. And second thing is openness and open source. And just one thing, which is my mojo, is there's a huge difference between an open source project and an open governance project from a foundation, like Apache Foundation, CNCF, whatever. That's hugely different. And especially in Europe, we're going to have a CRA pretty soon. So it has an impact on the open source project. So I mean that being a project under the Apache license is completely different from a project from the Apache Foundation in terms of governance and model. If you need more details, we can talk aside about that.
Yeah, I did a blog about this recently, again, looking for the past and to see how it shapes the future. So information lifecycle management was a thing back then where you made sure your data was on the right disks at the right age, and those disks would be configured for the best access, because you had to, because disks were very expensive then. But I think going forward with the vast amounts of data we've got, even though data's cheap to store, it still costs a lot. If you start going into these petabytes of data that you're maybe using for medical analysis and things like that, cost does come into it again. And then I think also a design aspect comes into it again, where you'd be tiering your data based on the access. You need to understand how the data is being accessed. And then you can actually say, well, let's define the micro partitions based on that. Maybe even choose the Iceberg format on AWS, so I don't have to pay because it's on demand. So I do like to think there's a bit of an architecture hat needs to come back on again. So whereas before, just chuck it in Snowflake, it doesn't matter. Snowflake dealt with it, which it did, but you pay a premium for that. And that premium is probably fine for most people in most organizations, but if you start getting to that, we have customers that their Snowflake bill's 14 million a year. They may look at saying, okay, well, maybe we need to cut down some of that cost and be more appropriate. But the benefit of Snowflake was enabling to get market share, get new products out very quickly. But now there's an economy of scale of thinking, right, is that the best approach for some of these use cases? So I'm no technical expert on Iceberg, but I think you can set the microregister to 1 meg to 100 meg. So you can, if you have data that is very small and the packets of data that come in are quite small, you can put it onto micro partition sizes that are going to be most performant for that. You may have a cost overhead of the different storage that you've had to pay there, but it's that trade-off. But now you have the ability to play with those knobs, which you wouldn't have had before.
Can I add something to the use cases? So, I'm in no way affiliated with Upsolver, but I think something which is quite nice about how Iceberg works, right, is that it facilitates streaming. So if you put something on a queue, it's actually really easy to just drop it into object storage. But then, from my understanding and from playing around with it a bit, it's pretty easy to kind of, manipulate that data after it's there. And I think for anyone who's used Databricks or tried Spark structured streaming way back in the day, it's like, yes, you can do it with that, but it's kind of hard. And then tied into that is, and I was having this conversation with the CFO where I used to work, and he was saying, well, our software engineers have one architecture. It's all on blob storage. But then you set up this other one. Like, why can't that just be the same? Yep. And, from my perspective, it kind of can be, right? If Iceberg lives up to the hype and, you're an energy company and you need to stream everyone's energy usage in real time, then that final gold layer, you also want to, serve to data analysts and business people. I feel like if you do that on Iceberg as it's meant to be, that's just one thing, without the pain of Spark structure streaming and Parquet, which would be quite cool.
Yeah.
I think it's important to note also that, in the end, Iceberg is an infrastructure. It's something that, it's true that you have these knobs and you can play with them, and it's good for the kind of power users. But if you look back at, there have been data lakes for many, many years, and then suddenly Snowflake comes along, and it gives pretty much the same as the data lake. But the benefit is actually that there aren't any knobs, but it just works well. And I think that as Iceberg matures and as the vendors and systems on top of Iceberg mature, we're going to get closer and closer to kind of that Snowflake experience where you just kind of throw data in and you don't worry about it, and you get all the services that you kind of expect without needing to pay the premium of having these Iceberg experts on your team. Like, sure, you're going to have some people who know Snowflake, but you're not necessarily like, 5 years experience in Snowflake in order to get it working. It kind of just works. And I think that's kind of the promised land, where then once it's like that, you're going to see a ton of adoption and a ton of lakes that otherwise you'd need kind of a more geared solution are suddenly going to just be able to use Iceberg with whatever on top and whatever underneath. And like, I don't think people should even know what Parquet and ORC are anymore. Like, it should just be abstracted away and just work. Just the same way that you don't know what the storage layer is in Snowflake or in BigQuery. I mean, it just works. Like, sure, they have their internal representation, but you don't care.
Yeah, we've touched on the 3 value props that, like, for me are the main things about the lakehouse, right? So there is cost. So I think there was a bit, and this is why the lakehouse offerings became very popular in the last year or two, is because everyone was getting kind of tired of the large bills, and the lakehouse really helps with that. The one that Yoni just mentioned, which is it just works, right? So it's a kind of similar to the managed warehouse experience where you're sort of used to, you go in and you need to know a little bit of how to like navigate the UI, but you don't really need to know how the data is stored or organized. And I mean, there will always be folks who do worry about that, like us, Dremio, etc. But from the user's perspective, it's the ease of, it's like, you've got your lakehouse. And then what was the third one?
Just to react about what you said and what you say, Yoni. I think I agree from a user standpoint.
Yeah.
But today we are not at this stage. Because people have to choose a catalog, choose a query engine. It's not only Iceberg, it's the whole ecosystem. And today it's pretty challenging to know, okay, which one I should use for this use case or this infra. I'm on-prem, I'm on cloud. What's the different kind of stack I have to build? So I agree, that's the ultimate target is really to have all package. I think that's why Upsolver, Dremio, and others, we are here. It's to provide something pre-packaged.
Right.
But specifically in Iceberg today, we still have a choice in the stack we want to build.
Yeah.
Which is very interesting in my opinion.
Right.
Well,
yeah.
well, there is an interesting thing where you have decisions that are committing you to something, and you have decisions that you can change from day to day. So, for example, picking a query engine, I could swap out my query engine tomorrow, and it'll just work. And they might even be based on the same infrastructure. I mean, sure, you'll have to port queries, and maybe, I mean, you can even use multiple query engines. It's like adding a query engine is very easy. Changing how the data is stored is very hard. So I think that, and I think Iceberg is doing a very good job of that, is that kind of consolidating the hard decisions that you have to make, and they're kind of committing you for, let's say, 10 years. Those decisions you can make today already, I think. And then what catalog you're going to use, like, swap it out later, whatever. It's not a decision that's going to lock you in the same way as how you put your data on disk.
Yeah. Jimmy's a catalog guy. So.
I mean, yeah, I agree for the stack, but if you want to switch from S3 to something else, good luck.
Yes, which cloud provider is one of those decisions that locks you in.
Yeah.
Which cloud provider and the storage format, I would say, are like kind of the 2 big ones.
Correct.
But the catalog, whatever, like, you can swap them out in a week.
Yeah.
Yeah, and the third one was what Hugo mentioned, right? It's the lakehouse is also enabling this like shared storage that crosses the boundaries of like different teams and different functions. So you can have like the same data in an Iceberg lakehouse and query it for your BI, query it for your ML. I mean, it's not super real time, and I don't know if it ever will be in terms of like, like instantaneous, like will you use it as part of your application infrastructure? Probably not. But at the same time, you can do definitely like data lakes were almost like, in my opinion, and you can definitely correct me if I'm wrong, but they kind of came out of this need for like a different kind of data infrastructure for ML use cases that weren't being solved by sort of the old school warehouses. So, and certainly a lakehouse is only building on top of lakes. So as far as training your models offline and stuff, the lakehouse is a great way to do that, much better than like a managed warehouse.
Yeah, we have one of our clients, and they're using Iceberg as the interchangeable file location between Snowflake and Databricks. So a lot of the data's been, even though the recs, both of them hate each other, but at least we were able to come and solve where they both win certain load. But yeah, having that that agreed structure and format that can be used to provide prep data that's been created in Snowflake has been there for a while, but they still want to use some of the more advanced features that Databricks provides. They have a facility to do that. It's only going one way at the moment, but they may even talk about actually having Databricks stuff going back into Snowflake. But the capability is there now. So yeah, so that's another real world use case out there.
Yeah, I mean, I think it's like in the BI space, this is having an interesting effect. The advent of the lakehouse and data engineering are kind of forcing BI to become a little bit more of a little more engineering focus, right? Like it's bleeding into BI, I think, in a major way, and needs to. There's a lot of stuff in BI that we really struggle with that are, in many ways, solved problems earlier on in the stack. And that's one of the things I've been really encouraged to see is as these kind of more engineering-focused technologies and approaches go into what you might think of as really traditional data warehousing spaces, that it's kind of forcing us at the presentation layer to start taking things seriously, like CI/CD and code control, and can I roll back and can I do a diff on report A and report B, which, historically we haven't been able to do any of that stuff in BI.
Yes, well, I'm actually interested now on this subject. So do you see the world of maybe Jupyter Notebooks and BI becoming just overlapping and becoming like that is your pain of your analysis, whether it's using machine learning underneath it or BI visualizations, it's one. Yeah.
I certainly see that happening. Yeah. And even both on the front end, like kind of the Jupyter Notebook style, there are notebook-based BI tools now, which are very interesting. And then on the back end, the back end meaning in the BI back end, the metrics layer, all of that is also, increasingly you can manage that stuff with Python SDKs, and you don't have to go back very far, where your only option in BI was UI-based development. And I really credit Lakehouse and data engineering with really forcing these ideas on BI people, because I think BI people are the absolute most resistant to change. And if you are a BI person, I apologize. I'm a BI person too, so there's most resistant to change of anyone in kind of the data world.
Yeah, also as strong features like materialized views and lower latency data come in, it kind of covers more and more of your use case. So you don't need to when we're talking about data that refreshes once a day, you have to pick and choose what you're gonna base on this, what you're going to read from there. But when you have real-time data with materialized views that just work all the time, it makes your life so much easier because you don't need to think about it. You're just going to get the right data if you just go to the same place.
I think we look at the positives. I think there's some negative things that can come out of this as well. Is that lineage of that data? If you get to the stage where you don't know how many hops the data's been on, where it actually originally came from, what additional transformations you're making. So I think that's something to be mindful of when you're doing this, and go back to the architectural hat is, you need to make sure that there is some sort of design. You actually know where your golden entities are, or if you're using the medallion architecture or whatever you want to call it, but the golden source of truth for each of these entities, that you need to make sure that is understood, and then any refreshes come from that, or you try and centralize any transformations into. If I turn that way, I get your mic, I think. Making sure that you do design where you do those transformations and consolidate where you can. Otherwise, it's going to be a very hard thing to support and maintain longer, and you may get misinformation that's happened because you're using an out-of-date version, or someone's added a transformation that hasn't been applied elsewhere.
And the Lakehouse makes it easier to do that, to have that lineage and to follow that, and especially with Iceberg live tables, which are materialized views. If you guys are familiar with Delta live tables, right? It's the same idea. You've got a declarative SQL that the user writes, so a BI person might do a transformation and create a metric, and then this SQL is behind the scenes, is run as a pipeline, and it's like kept up to date. And so you can have, you know, live table on live table on live table all the way through your embedded metric that you would want to show your users. So, and it's just a through line, right? You can definitely follow all the lineage from there.
And I think there's some kind of, Iceberg is opening new features. I'm thinking especially for BI, for instance, things like data as code. So you can manage, like, as you said, I want to do a diff between this tag and this tag to see what's changed. That's possible almost in Iceberg. I mean, not as is, but almost possible. The same for CDC and all this stuff. So I think by the architecture and the design of Iceberg, we can imagine new features that don't really exist today. I mean, for end users, it exists for internal users, yeah. But for end users like BI, and I'm thinking about data as code is one example. Yeah, I think that there are a lot of new features that will probably pop up depending on the needs of the people.
I think in that sense, the people who designed the Iceberg spec did a very good job, that they added a lot of forward-facing features like data branches and data versioning and all this stuff, which yeah, isn't really in use yet. Like, it's not really, the query engines don't really support it yet, and people don't really know what to do with it yet. But I think that going forwards, as data as code becomes more of a thing, and I mean, it's very powerful, and the infrastructure is there in place. And if it wasn't, then you'd be stuck. So I think that that's very positive, that it's quite a forward-facing spec in that regard.
Yeah, and the Iceberg community is pretty active and open to proposals coming from end users. I'm thinking about custom user-defined function, custom UDF, that we can have, for instance, as part of a metadata. That's something we started to discuss about. So it's not yet there, but it's a fair discussion and open discussion. So I think that it's always evolving. So we are on V3 of the spec. V4 is already in discussion. So it's moving forward.
Yeah, that's awesome. So, you know, with these Chill Data Summit events, we don't always cover the same exact things. So I'm realizing now today we didn't talk about like time travel, for example, which is like one of the strengths of Iceberg, right? So basically you can query the data as it is now, but you can also query the data as it was last month, you know, and so on and so forth, because those snapshots are stored, and you can set retention policies. And that also means you can like branch, right? So you can go back and sort of forward propagate from a previous state. So all of these like, yeah, what I would call forward-looking features, right? It's not at all hard to imagine, because I think as data engineers, we've been through a lot of situations where, you know, troubleshooting an issue, especially like, you know, some numbers don't add up in a dashboard or something, and, you know, like you have to go back to sort of the infrastructure, and then you're like, oh, I don't know what it was, you know, previously, but with time travel, you can solve that. So yeah, lots of really cool features with Iceberg. What do you think of the other sort of open table formats? Is it, Yoni and I have talked about this a bit. Is it sort of comparable? Is there anywhere that Iceberg really wins out?
I think one of them is going to make a comeback at some point. I think almost necessarily, right? Because it's like if you believe that Iceberg is going to be this way for you to be able to do any type of computation super efficiently, right? It's like big queries, aggregates, insert, updates. Like there will be something that comes around that negates it in some area, right? Maybe there's like some kind of zooped up S3, right? S3 is due a change. What about the optimized table format for that? It's sort of like we start off with this incredible database created by this company called Oracle, and then everything moves to cloud, and now we're going to open storage. You know, it just seems completely necessary that in sort of 10 years' time there'll be something else. I don't know what it is though. Probably not Hudi.
We'll be up talking about that in 10 years, isn't
Yeah. Yeah, I mean, S3 just announced compare and swap for objects. That completely changes, like, you know, the architecture of Iceberg kind of makes the implicit assumption that you can't do that operation on cloud storage, so you have to have a metadata layer that's in a catalog. Now that S3 introduced that functionality, I mean, you could actually get rid of the catalog. You could represent everything in Iceberg. So obviously these changes are they can shift the entire ground under what these, I mean, S3 can define a new storage class, which is much cheaper, but does some operations that wouldn't jive well with Iceberg. So definitely these things are very dependent on kind of what the cloud providers give you.
Anything missing in the Iceberg? We're sort of talking about the same things, but anything missing in the Iceberg spec that you would like to see?
Tons of things.
You get to pick one.
I mean, I would say that probably the biggest weakness today of the Iceberg spec is around cleanup. I think Iceberg doesn't do a very good job of facilitating cleanup, so cleanup becomes a very expensive operation. And I think that's probably a low-hanging fruit. Like adding a bit more metadata would be enough to make cleanup kind of go like this. Whereas today, like you're doing a lot of work and not doing it well, and all the implementations have bugs that might delete files. So it's like a bit of a mess around cleanup, I would say. Just off the top of my head, though.
Yeah, I think for me, coming from the more sort of like business side, it's just a way for it to just be a little bit easier, right? So you talk about all these features Iceberg has, like time travel and whatnot. But like what is the experience like? It's like if I'm like a VP of data, and my job is to restore trust in data in the organization and get people actually making decisioning on it. Like, how is this table format actually going to help? Right? It's like you almost need the stuff you get around the storage and the query layer that folks like Snowflake and Databricks have. It's one of the reasons I personally don't think BigQuery is great for like actual business ops, because it's so bare bones, right? As a data engineer, it's fantastic, but what next? So I think for me, just more around the Iceberg project, but nothing nitty gritty or technical. It's all coming, isn't it? So.
Yeah, that's a really important point, actually. So like the thing that you do lose when you move off of the managed warehouse-like platforms and go into one of these open table formats is like the heavily built out functionality that you get around your data store and data access. You've got, in the same UI, you've got notebook access. You can write SQL, and you can, access your data basically with any language, right? You can embed Looker or, whatever BI tool you have. So that sort of thing is both like, that's why the managed warehouse services can charge as much as they do because of that end-to-endness, but it's also nice, right? Like as end users, it's really nice to have all of that. So, the question is like, when do we get there with Iceberg? Because, market pulls, right? We probably can get to a sort of end-to-end, fully fleshed out Iceberg or other open table-based platform that is also not charging an arm and a leg, because you can always just export. You can always just switch to a different offering because it's an open format as opposed
maybe
to
Cloudera will come back, dust off the thing. Let's do it. Let's create another collection of Apache projects and badge it and call it a one product and then IPO and then crash. Now I think that may happen. There's someone's going to try and like stitch some of these things together and put it as a managed service piece. And then maybe that's negate it or reduce some of the complexity of going on to Snowflake or rolling your own, so to speak. Data engineers people are expensive. Engineers are expensive. If you add up, you add up your whole team's salary plus everything else. That's quite a lot of money. If half of you are maintaining the open source configuration, which you wouldn't have had to, then Snowflake may have been or another platform may have been a better alternative. So I think don't always have a look at the business use case and actually the cost of delivery as well. It may be that a good POC that you can spin up yourself, but maybe when you start scaling it, you need to go to a managed platform of some sort. But then maybe you get so big that you can actually go and build your own, like Netflix or Some of the other FANG companies out there, they get so big, it's more cost effective for them to build their own, and then open source that, or Apache that, like Twitter or.
It's important to remember that, like, in the end, open source is fighting Goliaths here. Like, you have in Snowflake literally thousands of developers working to make this experience, this like end-to-end super nice experience that, thousands of people are working on it, and they're good people. They're doing like really good work. So, open source, Iceberg has, tens of people. It's like 2 orders of magnitude less. So you can't compete. You can't say, well, okay, I'll just take this tiny like open source community and make something that competes directly with Snowflake. But with open source, you get these economies of scale where, as long as and I think Iceberg did a really good job of limiting the scope of what the open source has to do. So the open source can do a little bit really, really well. And then all these companies, like, you have like Trino, and you have Amazon, and you have all these companies that are building on top of that and building the additional layers on top, which give you that experience. But it's still, like, I think that in that sense, let's say if you look at Databricks, they have Delta, and then it's Databricks, but it's one company. So you're kind of, in a way, when you're using Delta, you're kind of making a decision similar to if you were to go with Snowflake. With Iceberg, you are open. It is really open source, but because they picked such a narrow domain where Iceberg kind of has to make the decisions, then they get these thousands of developers who are improving the ecosystem around it in ancillary products, which you can just buy and interchange quite easily. But you get like a super good query engine that thousands of people worked on, but you're still open and you can change it. So I think that leverage that Iceberg did a very good job of creating is going to allow that open source ecosystem, along with the vendors on top, to compete with warehouses on all the features, getting RBAC and getting like, all the whole 9 yards kind of thing.
It's quite exciting for me personally. I'm sort of biding my time, but for anyone that doesn't know what Orchestra is, it's clearly sort of in the name, right? It's like does data orchestration, but it's also like observability and cataloging. But if there's this huge move to Iceberg, then we can just sort of put something like Polaris into our software, and then maybe run it with dbt, and then boom, you've got Iceberg, you've got us. You literally don't need anything else, which is really cool, because one of the problems we always see is just the stack is too complex. I feel like that's also a trap that Iceberg may fall into, right? You talk about having different table formats and moving it between Snowflake and Databricks. It's like, well, okay, great, but wasn't this meant to simplify everything? Right? It's like, it would be really nice to just keep things really simple. But I think, one table format, one place that stays, a couple of query engines, maybe just one.
A simple world.
And I think the reason why it's so successful is also due to the model of the Apache Foundation. There are no vendor governance. It's something that is really important for us. But you can, thanks to the Apache license, you can build a commercial product based on Apache stack, and you can do it. And I think it's where the Apache projects, Apache Foundation projects, not Apache license project, are very interesting, is providing the framework to create your service on top of that.
Yeah. To enable that 100x that you get. Yeah.
Exactly. Yeah. I mean, we have a bunch of, today there are 400 projects at the foundation. Some are very small, but hiding gems, I would say. For instance, I created a project which is used in a satellite. I didn't know that. So it's very interesting to see that all the ecosystem built on top of these Apache projects, and there are no vendor looking, which is most important in my opinion.
Yeah, I think that, that's really, if you think about the difference of a vendor thinking, do I want to build on top of Iceberg or do I want to build on top of Delta Lake? I mean, that licensing question comes a lot into play. How safe am I as a vendor to invest in?
Yeah, I can confirm that. Yeah.
I think it's beyond the license. Things about, a project could be under the Apache license, but with a single vendor governance. If tomorrow this vendor decides to change the license, you're going to be screwed. Yeah. And there are no way to fight against that. When you choose a project from the foundation, you have a guarantee that it's going to stay under the Apache license with no vendor locking. And that's the fundamental difference between an Apache license project or another license project. We have recent example about companies decided to change the license.
Yep.
And that's a question for users today. And I can say that I'm discussing with different big players that they are providing open source project, but for a single vendor governance. And they are thinking about moving to a foundation, this project, just to mitigate the fact that they are losing users because people are concerned by a single vendor governance. And also with the CRS of the Cyber Resistance Act and all that's going to happen, they know that they will have to move to a foundation at some point.
You know, one of the things as I listen to us discuss kind of the values of these open source projects and everything that I'm struck by is for some people, for some companies, the vendor lock-in of something like a Snowflake or a Databricks is maybe a feature and not a bug, because they have someone to yell at, right, when things aren't going right, and they have a contract with a lot of money riding on it, and a sales team whose bonus is depending on them renewing that contract, and you know, when you talk about like what's the future of open table formats and Iceberg, it's very interesting. I live in the Detroit area, which, you know, is like manufacturing. I don't know, I think you would struggle to put together a data team who could manage all the stuff we're talking about right now where I am. Now, if you want to build a car or a robot, right, we've got that, that's no problem. So it's kind of, everything we're talking about is what I like and I find very exciting, but there's this interesting contrast with, you know, the commercial all-in-one vendors and what they offer. They're very expensive. They offer a great user experience, but I think we also should recognize they offer like a licensing and customer support experience that a lot of people actually need.
I mean, that was the Cloudera business model. So
Yeah, yeah, exactly.
Bad good example.
Yeah. I mean, but yeah, we've got clients got SLAs of stuff that's built on that, and there's monetary fines if they don't deliver that. So yeah, that accountability, you can shout at someone else, or maybe even negotiate some compensation if they do that.
Or they can do bug fixes and like
support.
Yeah.
So another thing I was just thinking, and I'm able to answer questions. I'm up here. So do you think there'll be like an Apache query engine that's going to work very closely with Iceberg? You hopefully probably don't really want that.
There is Presto.
Okay, right,
yeah. Presto is an Apache license, not Apache project.
Project. Yeah.
But I mean, Spark, Flink, they are all from the Apache Foundation.
Yeah, but there's lots. Yeah, true.
So Spark SQL, you're gonna have basically a good Iceberg experience. There's also Apache Arrow, and Jan talked about Apache Data Fusion. That's another engine written in Rust, which is pretty interesting. I mean, we have a lot of Apache Beam. Is another one coming from Google Data Flow. It's basically the SDK. So I think that the most difficult is probably to find in the 400 projects we have. I would say that about 150 around big data to find, okay, this one could be interesting, or package. And it's where I think Upsolver, Dremio, and others, we can package all this project and provide for you and users the best experience with the advanced features, deployment, and all this stuff. Because if you want to do it yourself, I mean, it's gonna cost so much in terms of engineering effort.
Yeah. It's important to note also that the query engine itself is kind of like the complicated part in a way. Like that's where, I mean, if you look at Oracle, how many engineering hours did they put into optimizing the query engine is like mind-bogglingly insane. So I think that having a really good open source query engine that's actually open source and there's nobody like kind of controlling it is going to be quite difficult just because of the engineering effort. And then when you deploy a query engine, you deploy like a ton of servers and it has to scale and it's complicated.
And Databricks did buy all the tabular guys, but
Well,
That's different story. But even a query engine from the Apache Foundation is not a single project. You're gonna use Apache Call Site and Flink and Spark and whatever, depending on what you need. And then you're gonna talk about the deployment, Yarn or something else, or now it's Kubernetes. But I mean, it's huge effort to assemble all the parts together and provide the optimization, the planning system, and all this stuff. It's what we are doing at Dremio. So
the deployment, I would say that I would imagine that query engines, like, there's Dremio, there's Starburst, there's Athena. I mean, they're really good, and they're cheap. Like, kind of like if you look at Athena, honestly, it's cheaper than rolling your own. You can't actually get to that price point with your own infrastructure.
But you're on the cloud.
But you're on the cloud, of course, Everyone's on the cloud, come on. No, I'm kidding.
Especially in Europe, depending on the business, you're on-prem. I mean, talk to financial or medical company, no way.
Yeah, definitely,
Okay, I was thinking for the last 5 to 10 minutes, we could open it up to a couple of audience questions. And if we don't mind turning on some of the lights in the audience area as well.
Shine it on them.
Yeah, spotlight. No? Okay.
No, don't have control of that. It's okay.
So, what I wanted to ask is, we had the data warehouses coming from 70s, more 80s, and they're still being used. Although, I think that the lakehouses are going to, we are going to stop using data warehouses from now on. That's what I believe. We had the data lake appearing in mid-2010s. So they lasted, I don't know how many years, but I'm pretty sure it was less than 10 years. Whilst we were still using the data warehouse. Now, what do you foresee? It's the times, because everything in life has a beginning and an end, right? So, what do you foresee as an end for the data lakehouse? Yes.
The data warehouse lakehouse. They're going to add another name to it.
I think that, the lakehouses, I think, are going to be pretty resilient. I think that the main Achilles heel, like the main reason why lakehouses would stop being competitive is if there came out a new form of storage that was cheaper / more efficient. I think that's generally what drives, if you look at the macro scale, what drives these things is cost. So as cost improves kind of by a factor of 10x, you're going to see a new technology evolve around that lower cost. And today, cloud storage is the cheapest alternative, and that's why it's robust. And I think AWS could probably reduce the price of cloud storage by a factor of maybe even 10 if they needed to, but they don't, and they like getting money, so they're fine with what they have now. But I think they have built in efficiencies of scale that they could reduce prices to be competitive with anything new that comes out. So I think that in that sense, it's quite robust, because that's going to be the forcing factor, is how much do you pay per pound of data is basically the question that you're going to be asking yourself.
I think the other thing that could happen too is if we come to a point where you can offer a OLTP, LAP.
HTAP. Hybrid Transactional Analytical Processing.
Yeah, because so with asset transactions in Iceberg and stuff, we're covered from that side, but I don't think anyone's gonna build an application off of Iceberg anytime soon. So
I think that's an evolutionary step, though. Yeah. I think that it could do it. It's just a matter of writing more code and getting more into the spec. And
I strongly believe that HTAP will happen at some stage. And in fact, there's some companies already doing general ledgers on that sort of technology, because you need to report on it as well as post the ledgers. It's achievable. All you're doing is transferring blocks from one sort of size to another, separate location. I think up until now it's always been CDC. I think you have to fix it across. But it's the same structure on both sides. If you can hide that and have something that points to it and it actually knows where to point that query to, whether it's an insert on the OLTP side or I think the guy's presentation that did earlier, talking about transformation being put into Iceberg, if you can store some of those transformation logic, elsewhere that's underneath the bonnet, so to speak, whereas the users never need to know, the result will be seamless then. They can perform some analytical queries that all include some business transformations into it, but you haven't had to move the data anywhere. 10 years, I reckon that would be the next thing.
I think even less. I mean, the infrastructure that was needed is actually a compare and swap on S3, which they just announced. So and literally just announced, like maybe a month ago or less. So nobody's built anything on top of that yet. But that was the infrastructure piece that was missing to enable actually the OLTP type use cases on top of the lake.
I think there's a second half to this question. We've been talking a lot about the storage format and the technology. I think the second half to the question in my mind is the actual design methodologies we're going to use, right? So we had the data warehouse, your Kimball or Inman, pick your side in that fight. And then my experience of the data lake in the mid-2010s was now there's this new place where you're just going to dump all the data just as it is, and you're never going to change its structure, and data modeling is dead, and all this sort of stuff, and that clearly didn't happen. It did happen, and it went badly. Yeah. And so then there's kind of this question about, well, how are we actually going to design these things, right? Like what are the schemas going to be, and how do the schemas and entities relate to one another? And I don't know where we are on the data mesh hype disillusionment cycle right now, but I think that's really the idea I've seen that at least offers something concrete and different, where we might have essentially a microservices architecture for data or data products, where the data products are able to communicate with one another over something like an API in a truly distributed, decentralized system. We'll see, but people are trying it, so we'll know soon enough.
And the GPTs help with that vision.
Yep. Yeah, that's a huge.
I think it's just an evolution. I mean, if we talk back to the question, are we at the beginning of a lakehouse or studying the end? I think we are still at the beginning, because everything we are talking is evolution of a lakehouse.
Yeah.
Your pipeline doesn't basically change. The evolution evolved, meaning the technology evolved. Look what happened for where Iceberg is coming from. At Netflix, they started from Hive, and they added metadata on top of Hive. But at core, in terms of architecture, it's basically the same. The storage is similar, we have data files and so on. So in my opinion, everything that we're going to see is more evolution of the platform, but not the architecture. So I think your pipeline running currently on Lakehouse, they're going to run for a while. They will change for sure, depending on the technologies, but the architecture is going to stay the same, in my opinion, for a while at least.
Yeah, it's like we're not exactly at the beginning of the lake house. It's not like the data lake sucked and now it's the lake house. The lake house is kind of the more mature evolution of the data lake that doesn't suck anymore. So it's not like we're just starting and maybe we'll find out that in 6 months, oh, we made a huge mistake. This is kind of 10-year-old technology that's just matured to a point of a step evolution. So I would expect that this is going to be with us for a while.
I do blame marketing, so even though I do run marketing in my own company, but I do blame marketing to some degree. They come up with these names, like the modern data stack, which is very much a marketing sort of, lake house is, Databricks is sort of like trying to differentiate themselves between what Snowflake were doing at the time. So we have to like dust off the names to some degree and think what really is under the bonnet, and it is an evolution, I think, and it's just always going to evolve. I think that the names get given to it just for to give a marketing to give excuses for the failures that happened in the past, because you can always blame someone else or blame the approach. You don't blame the people or yourselves normally. A pinch of salt sometimes on the name to some degree.
Let's do one more short question from the audience.
Two more? Yeah.
You in the back.
Yeah, the one, you raised your hand over there? Yeah, you can go.
What kind of career advice do you have for recent university graduates in the data domain?
I mean, I would just say read a lot, stay abreast of technologies. I don't think, it's not a one winner fits all, but also, I mean, it's actually quite nice today that these technologies aren't as complicated as things used to be. So it takes a lot less time to get into something. You don't need to be like, oh, I have to be an Iceberg expert, otherwise no one will hire me. I mean, you'll learn that on the job in the place that teaches Iceberg. I do think Iceberg is like a big thing. and it's worth knowing what it is. But I think that today, like, there's a lot more opportunity for recent graduates than there would have been previously, because these things aren't actually that complicated, and then people aren't expecting specific domain expertise like they would have in the past. Like, if I was hiring an Oracle DBA, they had to have like 10 years experience. Now it's like, you know, I need to hire someone competent, and then I'll teach them what Iceberg is. It won't take long.
Yeah, plus one to that, 100%. Yeah. And also, this guy's podcast and that guy's podcast. Listen to this. There's some really good advice.
Pragmatically speaking, I would say try to join a company that is like quite data first. There are a lot of companies that say they're data driven that aren't, and if you join somewhere like that, you're never even going to come into contact with a Parquet file. So, you know, you got to learn somewhere.
Yeah.
Yeah, I mean, I think when it comes to your data career, there's two ways you can really distinguish yourself. The first way is to be the most incredible technical person on any team you're ever going to be on. That's pretty hard. The other way is...
Also, it's less well-defined in data than in software.
Yeah.
What is a really technical data person?
Yeah.
I'm gonna say, it's more software engineering more than data engineering.
Yeah. The second way is to be the person on your team who is best able to understand what your user communities actually need and deliver that thing. And those two skill sets are not always all that closely related. And my advice to someone entering data right now, just purely based on how my career has gone, is to actually lean into the second one. To be the person on your team who can figure out, can see through what your users tell you they need, and into what they actually need. And the way you pick up those skills is not something you can read in an instruction manual, right? You need to work with them. You need to learn about their business. I always tell people on the podcast, like, you know, half of the data books you should be reading are not data books at all. You should be reading fiction and biographies and learning about human beings and what makes them work. Because ultimately, there's a lot of things you could have gone into that involve sitting at a desk typing things, but you chose data, and I believe among all the technical topics you could have gone into or technology-related fields, you picked one that has the greatest contact point with other people, right? And so I would lean into that.
Yeah, I'd add to that I think that a lot of people are hesitant to follow that advice because it feels super domain specific. So it's like, you know, I'm going into this company and they manufacture widgets, and then I'm going to learn everything about the data domain of manufacturing widgets. But they're like the one company that does it. So am I not pigeonholing myself into just understanding that data domain? And then I'll go to some other company and I know nothing. But honestly, the process of learning how data models into a specific domain is very transferable. So when you learn that domain, that super specific domain that nobody cares about, you're developing tools where you'll be a data expert very quickly wherever you go. And those people are super valuable. Like, they're kind of the 10x engineers, the 10x data people are the ones who understand the business case and can apply that, understand kind of where does the data model match and not. And being able to learn that is a transferable skill, even if any specific implementation of it isn't. So I would definitely agree and support that advice and kind of tell you that, like, don't worry about getting super specific, useless knowledge, because that's going to help you later on anyways, just learning how data models apply to the real world.
Okay, we'll do one other question because a hand came up, please.
Yeah, it was just about, so you talk about evolution, and because I'm a BI developer, so I do find myself kind of looking more at the engineering side, but I also see the data scientists in my team looking more at the engineering side because the data quality isn't there. And there's like two schools of thought in my workplace right now. One of them is democratize the data and have like a self-service layer. So, you know, teams have access to the semantic layer, they can build their own reports. But another school of thought in my workplace is no, we should keep everything within the data team. And it's not a good idea to start democratizing data. What are your thoughts on
If your
where to go?
if the semantic model's been defined, it represents how the business operates, then there should be no reason why users couldn't use that semantic layer to report on it. What I would draw the line is don't give them access to the raw data. Give them access to the raw data, multiple people access, they're going to come up with their own modeling and own rules for it. But if you have a well-defined semantic model, then I would allow it, because the thing's going to happen is they're going to find, you're going to go to a business user and they go, oh, it's really good. Oh, but I've got another idea now. What about this dimension? Then they have to go back, report change, release, 2 weeks, and then they'll ask another question. You want to be able to provide something that can answer not the first question they got, but the 5th question they've got from looking at the first question.
Yep. And this is an area, like, the reality is you're going to have to do both, right? Like you're always going to be producing some amount of content for people, but you need to, and I think increasingly, so like if you're a BI person, where is BI headed? I think the management of the metrics and the semantic layer and understanding what your users need and making sure that that's available to them in an easy to consume fashion, it will be increasingly important for BI as the creation of visualizations or the answering of simple questions is taken over by AI. Is AI, I mean, in some future, it will be able to produce presumably most of what you need, but that future, I think, is still far away. In the meantime, BI people have traditionally defined themselves by their expertise in a particular BI tool and their ability to deliver outputs in that BI tool. And I think that as AI gets better and better at answering that first line of questions, developing that visualization, or even building the first draft of a dashboard, what your job will become is about being the contact point between data and business and curating that semantic information so that both types of intelligence, human and machine, can easily find it and manipulate it.
Add something real quick. The question was, should we do self-serve or not?
Yeah, yes.
Yeah. But like generally I find the self-serve works really well. The data is squeaky clean, right? You go to Sainsbury's self-checkout, it works, you're out, happy days. But if it's not scanning, it's the most annoying thing in the world. And it's kind of the same with self-serve data. And you said something which was that the data quality is not there. So I guess if that's a barrier for people getting trust in it, then probably not self-service time yet.
I mean, I would say, to give you some actual concrete advice on your predicament. I mean, this is a problem that a lot of organizations face. The reason is that the data team is swamped. They don't have enough bandwidth. So the BI people are saying, well, can you add a column? And they're like, sure, we'll add a column, we'll add it to our backlog. And then 3 months later, you ask them again, and they're like, yes, it's in our backlog, we're working through it. And you get your column 6 months later, and that's just too long a life cycle for a data request. And it's a simple one of just adding a column. So the data teams are swamped, and so you say, well, they're not providing the service. They're supposed to provide me with data. They're not doing it, so I'll self-serve. The problem with self-service is that you take the best data practitioner and build a query, they're going to need to work an hour, and they're going to go through 6 iterations before the data's right. That's the absolute top, the top hires, the people who are paid $1 million a year. Those people are going to need to go through 6 iterations to get correct data. And that's not the entire team. People are, there's a gamut. And then what happens is that when you're self-serving data, you end up serving wrong data. You end up, the business users end up actually getting incorrect, tragically incorrect insights because the data sanity checks and the ironing out the kinks doesn't happen when it's happening at the top. It has to kind of happen here. So what I would suggest, I mean, this is a rock in a hard place. The concrete advice I would give is that the data infrastructure team needs to improve their tooling, because they need to give you service in less than 6 months. They need to give you service in a week, and they can do that today with better tooling. So that would be the concrete advice. Self-service is a stopgap. It's something that you can do in order to survive, because you can't give the data in 6 months, but it's not going to serve the business.
Have you
Why my SaaS tool?
Have you considered becoming so unfriendly as a data team that they stop asking you questions?
I was pro self-service because I am swamped, but actually listening to you guys, I'm probably going to back away from it. I'm the only pro self-service person in my team. Everyone else is like, no.
No, the reason I was smiling while you were asking the questions and while these folks were answering, this is a debate. Like, it is definitely not something that's solved, and, you know, we're not going to agree, and, you know, we have to move on and let everyone eat. But it's not, there isn't a right answer to this question, right? So, okay, with that, we don't have any answers, but thank you for listening to us for over an hour, and hope this was useful.
Thank you.
Thank you to all the panelists.